So the next presentation is from Jörg. It's called Clean SQLScript. Write code that your colleagues don't hate you for. I think this is something which might be important in your projects. Yeah? Might be important to consider. Well, it depends what colleagues you have actually. So now you get the framework. So last presentation was about the framework for ABAP development tools. Now you get a mental framework if you want to be kind to your colleagues or not. Yeah, I'll pass to Jörg.
Thank you, Konrad. Can you hear me? Oh, it's very loud. Is it better? Yeah. Okay. Welcome to my talk about clean SQLScript, write code that your colleagues don't hate you for. Reading code can be very emotional when you read, and normally these are not the emotions of love and well-being. It's more the other way around. And from time to time, I get some examples from my customers, and yeah, I put everything together and tried to make a good talk about this topic in SQLScript. This is not my first talk about clean code. My first clean code was Clean ABAP 2017 in Waldorf at a SAP Inside Track. My first talk at a SAP Inside Track at all. 2 years before the Clean ABAP, the first commit to the Clean ABAP repository of SAP. So for me, this is a long thing with clean code. Jörg Brandeis is my name. I'm a trainer. Mainly I'm a trainer doing trainings. When my SAP module is the BW, there I'm working mainly as a developer and consultant. And once I wrote a book about SQLScript. And because I wrote a book, I'm an expert. And when you're an expert, you're asked to give trainings. And yeah, this is the short version of the history. I'd like to announce a few events, trainings in Mannheim, CDS, ABAP, SQLScript, and of course, ABAP conference. Very important, free conference online, live in Vienna, live in Mannheim. It's for free. Please register. Next thing, one advertisement. As for Fit, together with Cadaxo, sponsors of this SAP Inside Track, we are doing workshops about the important modern topics on the ABAP stack. What's happening there? Hey. Okay, we are back again. That was just advertisement. Okay. Ads filter. Short disclaimer. The code in this presentation is not one-to-one runnable, not all code, because I want to show you principles and patterns in code, so you cannot execute everything one by one. And so I typed many things in the text editor, and we're not able to run it, but I think the ideas should be clear. Okay, I start with a popular quote. Any fool can write code that a computer can understand. Good programmers write code that humans can understand, from Martin Fowler. It's, yeah, that's a good quote. It's very pregnant and okay, prominent, yes, sorry. It's not true. Not any fool can write code that a computer can understand. We are talking now about complex code that is not so easy to write. And the big problem with complex code is that the most clever people write the code that think, hey, that's obvious what I'm doing here. That's so easy, it's obvious, but it's not maintainable. It's not maintainable. It makes everything hard to read. But if you are a genius, it's no problem for you. You just see it and say, okay, this and that, obvious what it does. So not any fool can write code that a computer can understand, but the geniuses don't think about readability. This is a problem. This is a small example from code, really project code. I saw this. I asked in a training a customer, can you show me some code of your colleagues? And they started with this. And yeah, and this was 1,500 lines like this. Okay, what can we do? What can we do? Okay, we can change the resolution of your screen or the font size. This is an option, but it will not get better. You only see more of the mess. This is this is a problem, and yeah, you see, this is not trivial. Maybe not everything is required here. You can discuss about some details, whether you need a 2-decimal function here, or you can talk about details, but at the end, it's a mess. You cannot maintain it anymore. The worst thing I ever saw was this select. Now we have two options. One option is I give you 10 minutes and you tell me what it does. And I'm sure no one will find it out. I'm sure. It's unreadable. It's definitely unreadable. Nested expressions, nested inside expressions, nested inside expressions. You can really, really hard understand, especially because this is for a use case that you would not expect. You would not expect 60 and a timestamp for the seconds. Second 60 is not existing normally. This code should fix this problem, but it's a mess. You cannot read it. What the fuck? This is from the clean code book, one nice image. What the fuck per minute in a code review is a good measurement of code quality. You cannot avoid this totally. That's obvious. From time to time, you stumble over things that you don't understand. But bad code, you always say, what the fuck? What is this shit? Okay, what can we do? Ask ChatGPT. ChatGPT helps us everywhere. So I asked ChatGPT, give me the top 10 clean code principles. And I got this list. And this does not fit one-to-one to SQL. This is a problem. SQL is a little bit special. When you say a function should have at least a maximum 20 lines, and if your table has 200 columns, you cannot do this. So, and keep functions small, for example, normally we don't have so much functions, but there are some principles that are obviously possible. Meaningful names, single responsibility principle, do only one thing at a time. That's definitely something you can do. Keep functions small. I can translate it to keep select statements small. Dry principle, don't repeat yourself. Definitely worth looking at. Formatting. Formatting could have helped in the example I showed you before. Also the minimize nested control flow. This nested, I go back, this nested expressions here, this is not minimized, this is maximized. A case with SQL functions and concatenation and operations expression, this is really a mess. Minimize this. Single level of abstraction, also an important thing. Don't combine totally different operations like aggregation and joining and calculations in one select statement. So we can translate most of the topics to SQL, and I try to do this. But before before I will show you something that's very important, how our SQL code will be executed. This is the crucial point here, because it's not either fast or clean. Totally different dimensions. They have nothing to do with each other. You can, and I will show you a small example. My typical example, I have a task management system with tasks, and I do a select to the users, to the assignees, the task, whom the tasks are assigned to, first name, last name I want to see, and then I do another join to the projects. I want to get the project managers, which are also users, and I'd like to see the project manager's first name, last name, a small use case. And here I have two different approaches. On the left-hand side, everything in one big select, 3 joins, 4 tables or 3 tables. One table is there 2 times. And on the other side, on your other side, we have a totally different structure. I do the select on the tasks. I do a join with the first table, users. I do a second join in the next step with the projects to get the project manager. And in the third step, I'll get the first and the last name of the project manager. Total different style, completely different. And the big question is, which one is better to read, better to debug, better to maintain if something got wrong? And of course, which one is faster? Which one takes less memory? Which one takes less resources? And this might be surprising. This might be surprising. Do you have any guesses? Which one is faster? This one, the first one, is faster. Okay. Any other thoughts? They are the same. Which one consumes more memory? Yes. Okay. Some of you have are sure about this. Others are more more undefined. Okay, I try this. I want to try both statements and have a look at the execution plan, because this is the only truth. What will the HANA do with this? This is the first statement, everything in one big statement. And when we execute it, when we have a look at the execution plan, plan with, execute, we will see, just a second. Oh, okay, I have to create a new SQL console, no problem. Don't save. We execute it. And better than executing is plan with. Have a look at the output, and we will see here, expand all. I make it a little bit bigger, and maybe 75% or less. Then we have one big join operation here, doing all this left outer joins and 4 table accesses. And the users table is involved twice. So yeah, this is the result here for the left side. And I do the exact same for the right side. I copy my code, put it here in the SQL console, execute the plan with, and this was the step-by-step solution. And now what's interesting, when we go to the same resolution and expand it, expand all, we have really exactly the same logical execution plan. When we switch between them, you will not see a difference. And this is very impressive. It doesn't matter how you write your code. It doesn't matter. This is first thing we learned here. Here I have the same on the slides for the documentation. Another example, another example to very, very similar queries. It's the same query as on the left-hand side before, but with a small difference, aware clause, just filtering on the data. Once here, once there, with a different condition, slightly different condition. And what will be the result? It's not this or that. The result is different execution plans. Why? I don't know. Ask the optimizer. It's not my job to find the best way. I really don't know. I will not show in the console, but you can do this at home with this data model. You get a different execution plan in a different engine. Here we have the hex engine. Here we had the column engine. So it's not under our control. We cannot control how the execution will be done. A last example about optimization or writing code. Once an Oracle expert told me an not exist predicate is very expensive. Don't use not exist. Better do a left outer join and filter on the null values. This is a little bit complex, but from the result, it gives you the same. Okay, we tried it out. We found out it's exactly the same. It's exactly the same execution plan for both. 100% the same. But the left version with a not exist is much better readable because I just want to filter users. I want to filter whether a task here is not existing, the users without tasks. And here I do a left outer join. Normally my intention when I do a left outer join or a join at all, I'd like to get data from the other side. Here I exactly don't want to get data. This is for the clever people, the really clever people who understand this. But most people think where condition means filtering. This is much better readable. Exactly the same execution plan. So conclusion, write your code as you like. Don't care about performance. Okay, there are some sins that you should avoid, but this is not the topic here today. But it's not an opposite, clean code and fast code. It's not an opposite. You can also have slow, clean code and slow, messy code. Everything is possible. You can't control the optimizer by writing code in a certain way, unless you use hints. With hints, you force the system to do something in an exact special way, but we don't want to use hints. Readability and performance are not contradictions. This is the first important takeaway here. And now let's go into the details. What can we do? How can we write nice code? Formatting, first of all, definitely worth to do this well. Formatting is very, very important. ABAP Cleaner, for example, can format your ABAP SQL, but in SQLScript, you are lost. You don't have a chance. Please ask ChatGPT to help you. ChatGPT can do formatting for SQL very well. At the end, it's not so important how you format, but format, align, do line breaks. This is something you can get really, really cheap. Even this is a bad example because it's much too complex for one field here, but at least it's a little bit formatted, so you can improve the readability even of bad code when you say ChatGPT, please format it. This is the output of ChatGPT. You can improve it a little bit. Optional keywords, another important thing, don't omit them. Always use optional keywords like as or outer. You don't need to write outer join, you can just say left join, but for readability, write it down, then everyone can read your code, and it's much better than this A, B. This is really hard to read, and yeah. it's not a good idea to do so. Next topic is keep your functions small and single level of abstraction. Don't do too much things in the same time. Don't mix, for example, a union, a join with a group by and case expressions. When you do these things at the same time, it gets harder to read. Make every statement trivial, really trivial, that you can see, oh, it's just a join and you have all your fields, or it's just an aggregation. But when you combine them, it gets complex. And yeah, you can do this unlimited, this combination, because of the concepts of expressions. You can in SQL, I think nearly all SQLScript AMDPs you can do in one single statement. Technically, it's possible, but unmaintainable. For the machine, it's totally doesn't matter. But for the readers, of course, it does matter. Meaningful names for table variables, I think this is the same then everywhere. Correlation names, something special. You give a table access a name. You should do this, and you should use it everywhere, even if it's not required for unique, or if it's technically obvious which one is meant, you can omit it, but please do it. Don't use ABC as a correlation name. This is the stupidest thing you can do, but you see this often. You see this really often. You must not write the complete long names, but you should find short names. When we talk about short names, the SAP has many short names, and rename them. At least if it gets complicated. If you have much code, rename them. Then it's much easier to understand what you are doing if you are more technical and less from the business side, and if you don't know all of these shortcuts here perfect. This one is a very good thing. Normally the virtual data model is doing this for us in our days. If you are on an S4 system, of course, better use the data from the virtual data model than from the database tables directly. Then you don't have to rename them. But in a BW use case, for example, you have to rename. Interesting point here is I have not written the code on the left side, on the right-hand side. This was ChatGPT. I asked ChatGPT, please find, here you can see it. Kannst du bitte diese Feldliste im SQL schöne englische Alias-Namen im Pascal-Case mit as hinzufügen? ChatGPT is so clever, and for these topics, it's perfect. It's perfect. It can help us. Of course, you have to check whether this is feasible or not. You can also pass lists how to translate things to ChatGPT. ChatGPT can be very helpful. Okay. Okay. Then inbound projection, something I really like. I did a lot of work in BW transformation routines. And of course, we need table access to database tables. And it's a good pattern to do a table access, all table access, database table access at the beginning. At the beginning, do just a small inbound projection where you give a table variable a reasonable name, not ECPO and VBUC and things like that, but give it a reasonable name in the first step. Filter the field list to the required fields, and only to the required fields, that you don't have the complexity of 200 fields, but only the 10 you are interested in. Unique names, meaningful names. Unique, I mean, globally in your routine, you should have exactly one name per table and field. Then later on, I'll show this here, later on, you are free to use the asterisk, which is very, very important. Avoid mention all fields all the time. In ABAP, you learned don't use the star. Don't use select star. The asterisk is not a good idea, but in SQLScript, not a problem. Use it. Then you don't have these extreme long SQL statements. Just reduce it to the things where the work is happening, where you do something, and the rest is just all of the above. Don't mention it all the time. Then you get small statements. And here it is definitely allowed, but one problem are naming conflicts. If you have the name, for example, the record number in one table and the record number in the other table, and you're doing a join, you cannot do this. So at the beginning, rename them unique, and later on you can use this asterisk, and this is not a problem. And when you calculate something, like here, you have the problem that might be your name that you want to calculate is already in this all of the above. Then just use a prefix like calculated. This makes it easier. Then you don't have problems with naming conflicts. And this is special for BW routines, outbound projections. It's really, really hard, really a hard thing to meet and to fit to the outbound table structure. If you have 200 fields, you have to mention all 200 in the correct order with the correct name, with the correct data type. It's really, really hard. Do this without any other logic. Then it's quite easy to do steps like this. If you combine this with logic and later on something changes, everything breaks. This is really something, a separate step at the end makes it much easier. And now one of my favorites, and I think one of the most important problems in SQL in general, not only in SQLScript. When I talk about SQLScript, I mean something with table variables. But you can think of the exact same thing with the common table expressions that are also available in ABAP SQL, for example. Table variables and common table expressions are very similar. Here we have the problem of the nested subqueries. So for Oracle developers, this nesting of subqueries is very common. I don't know why, but they can understand what they are doing. It's extreme hard to read this nesting of subqueries, and it can be unlimited, be nested. That's quite possible. But it's a bad idea because you have all the complexity in one statement. And if the result is not 100% what you expect, you start to search. When you split this up in table variable, next table variable, next table variable, you can read your code step by step by step by step. You can debug. You can. It's much easier to find problems, and you can give the single queries a reasonable name. Really important names that you explain what you are doing here and not just do it here. Here, this is anonymous. You don't have a name about, and then you can guess what's done here. Another nice thing. It's from the same customers that I showed before. Really, really, really huge expressions. And when we go back, the big picture I showed you first was this is just a part of it. What's very, very often the case is that you have multiple similar or identical expressions in these field lists. Identical expressions, you can either calculate them once in a previous step, or you can calculate them 100 times, one after the other. If you do this once, of course, your code gets much more complex, less complex, so you should do it. And ChatGPT can help you with this. Ask ChatGPT, please find common expressions in my field list. And these are candidates for the previous step. Here in this example, and I ask, okay, list me how often they were used. That's great. ChatGPT is doing the hard work, and I just have to say, okay, I create a new column, cumulated order quantity divided by total order quantity, calculate it once, and use it 10 times later, the result. Yeah, this is about duplication. Don't repeat yourself. I think when I look at the watch, I skip this one, but this is also a good one. Case expressions. Very often we have one table, but two kinds of data. One should be handled, for example, here it's an indicator with a value s. Then we want the 0 values here. And in the other case, we want to have the field copied. Sometimes you have also 3 or 4 different branches how you treat your data. And the dozens of cases with the same conditions are obvious, not don't repeat yourself. This is repeating 20 times. An easy solution for this is split your statement. Do one simple statement for the indicator equals s. This is just a constant 0 for all values. And the other statement is here, just copy the values from the fields, and later on do a union all. Union all is an operator that is extreme fast. And the only crucial thing is the conditions must be that you really have disjunct table without overlapping, without losing any data. This is a little bit tricky, but when you got this, it's much better readable. You see, okay, indicator S, trivial, indicator not S, also trivial. And yeah, I already showed you this. This was in the start. I think this is one of the last ones. Union. A typical really ugly pattern is union all, big queries, union all, the next big query, union all, the next one. It's getting longer and longer and longer. No, split them up in small or in single queries, single query, and at the end, use this star to union them. Then you see the relevant offers are this, you gave them a name, the relevant invoices are that, and then you say relevant records is the combination of them. So now my time runs out. Brackets. Last really, really important point, brackets. Combination of and or. Really a pitfall, not only about clean code, but also about correctness. This is often that you have a working statement and you want to add one special case later on that you forgot, and you put an or afterwards here. But what is the effect of this or? What is the effect? This or that? Make it clear. Use the brackets. Then you will not be surprised. Comments, of course, in the book Clean Code, the advice is don't use comments. That's total shit for SQL. Explain your steps if required. That's obvious if it gets too complex. And now, last slide here, all the principles. And here I put my advice to it. So everything is, or most things are possible except graceful error handling. There is no error handling in SQLScript, or not for the use cases for BW transformation. But in general, you can do so much things about clean SQLScript. You should do them. So thank you for your attention.
Thank you, Jörg. Any questions for Jörg?
Hi, G'day. I've got just a quick question because we had an issue, I think it was 3-4 years ago, when it comes to SQL scripting and SDA. So when we push SQL down into another system, the optimizer somehow sometimes did not properly send a good SQL pattern to the next system, or got too much data, or did the join in the calling system stuff. Is there any experience you had when it comes to SDA and how to formulate SQL script to make it compliant or better performance-wise when using SDA and pushing SQL in another system?
No, I don't have experiences with this, but the challenge is the SQL will be executed in 2 different engines, and one engine decides, okay, a part of this I will delegate to the other system, and yeah, this is something that is not working as good if you have everything in the same system, which is the normal setting in the BW transformations. So this is what I'm used to. So sorry, I cannot help you.
First, thanks a lot for your session. So it's very useful, and I enjoy really it. And question is, when you show all these cases and rules which we should do in our SQL scripting, I'm always remembering about calculation views. And most of the things which you told us, you automatically enforce it by the calculation views to do it. You separate nodes. You have a separate calculation. You don't mix things into one node. And we always make a projection from the beginning. That's and the question is, maybe it's better to develop calculation views instead of SQL scripts, and you see it all in one screen. All your program for 1,000 lines, you have it in one screen. It's easily to understand, easily to navigate, and so on.
Okay, calculation views are really built for performance. So some things are not allowed there because possible performance problems. So SAP is aware of this, and the readability of calculation views. Yeah, it depends a little bit. It depends a little bit. I prefer the code. I think code is, but it depends. Calculation views are really fast, and they enforce this. You have either a projection node or an aggregation node or a join. So it's exactly the same. And this is also a proof for what I told you for the optimizer. It's not bad if you split into multiple different nodes. For the optimizer, it's not a problem. Oh, I don't debug. I execute code in the SQL console, which is much more comfortable. And then you can much easier filter. You can much easier project the data that you like. So normally I avoid debugging. SQL console, execute everything in the SQL console.
All the SQL experts above you.
Hi, Marco. I want to ask you, I saw your that you compared the 2 queries using that tool. Do you know other tools that are useful to compare the query and to evaluate the differences? For example, if you have 2 queries that are quite similar, but you want to understand which is the better one, do you know some other tool that can be used?
You mean the planvis to analyze it? This is the tool I'm using normally to get some ideas what the system is doing with the statement. This is the only tool I use. Sometimes I use explain, but most of the time the planvis. This is the best tool I know. But there's also another web-based tool, very similar SQL analyzer of SAP in the Web IDE and in the Business Application Studio available in the Database Explorer. But it's the same. It's the same in a different UI.
Is there a way to parallelize the execution of a SQL statement?
This is parallelized. Everything you
Not always.
This will be, and also the single statements will be parallelized. There's a easy proof when you execute big statements, and when you look at the CPU load, and you see that it's more than 1%, and if you have 100 CPUs, then there must be parallelizing. Okay. And normally parallelizing is taking place also in single statements. And
should be done automatically.
Yeah, it's done automatically. You don't have to care about. In extreme situations, you can also tell the system parallelize this and that, but normally you don't have to. Everything will be executed because the system thinks a little bit different than in an ABAP program. In an ABAP program, it goes top down, step by step, one step after the other. In SQL, it goes bottom up. What should be the result look like? And then the optimizer finds out, okay, what steps do we need, and so on. And then it finds out what can be processed in parallel. And that will be processed in parallel normal if you have enough resources, if you have assigned enough resources to the processors. But normally this is the case.